Okay, so we are going to look at using sec, cosec and cot, so the reciprocal functions that you learn on the 18th of June. If you haven't caught up with that lesson before you do this one, can you please go back and catch up with the lesson from the 18th of June? And that was set by me, not Mrs. Morrison. Now you can use sec, cosec and cot in really similar ways to how you use sine, cos and tan at the beginning. And also how you use sine squared plus cos squared equals 1 and things like that. You can use them to simplify things and you can use them to prove things. So we're going to start here in a really simple way by using them to simplify things. So for this one, we've got sine theta, which is an original function, so I'm going to leave it as it is. We've got cos theta, which is 1 over tan theta, and sec theta, which is 1 over cos theta. And if you get mixed up about which is which, remember to look at the third letter. The third letter of sec is C, so it's a reciprocal of cos. The third letter of cosec is S, so it's a reciprocal of sine. The third letter of cot is T, so it's a reciprocal of tan. So up to this point I've got here, but there's nothing here that's going to help me out. The tan's not going to cancel with the cos. I've still got 3 different things that aren't going to cancel down very nicely. So I'm probably just going to leave that for now. Instead, I'm going to write sine theta as sine theta. Now, cot is the reciprocal of tan, and tan, is sine over cos. So the reciprocal of sine over cos is cos over sine. And sec is 1 over cos. And now you can see that because these are times together, that sine is going to cancel with that sine, that cos is going to cancel with that cos, and you are left with 1. So it really has massively simplified that. You could have got to that from back here because you could have spotted that sine over cos is tan. So tan times 1 over tan is 1, but I think it's easier to see it from here. Right, if we look at B, we're looking to simplify sine theta, cos theta. So I'm going to leave them as they are because they're original trigonometrical functions. Sec, which is 1 over cos. And cosec, which is 1 over sine. Right, so sine theta cos theta times 1 over cos theta is sine theta cos theta times 1 over cos theta. Sine theta cos theta times 1 over sine theta is sine theta cos theta over sine theta. And then the coses will cancel out to leave you with sine, and the sines will cancel out to leave you with cos. So that's your simplified function there. There you go. So quite straightforward, really. Another example, so a proving type of example this time, is prove that cot theta cosec theta over sec squared theta plus cosec squared theta is exactly equivalent to cos cubed theta. Remember, these 3 lines means it is exactly the same for all values of theta. Okay, it's not an equation that we solve, it means that it's the same as that. Whenever we're trying to prove an identity, we generally start with the left hand side and try to use some things that we know to turn it into the right hand side. Now, if I look at this one, it's quite complicated. We've got 2 reciprocal functions in the top and 2 reciprocal functions in the bottom. So I'm going to look at each of them in turn, just so the page doesn't get too busy. So if I look at the numerator, I've got cot theta cosec theta. So what can we do with that? Right, cosec is something to do with sine. So I know really I'm going to write that cot as a cos over sine, not as a 1 over tan. So I can change that one. So the cot is cos over sine. Cosec is 1 over sine. So the numerator is cos theta over sine squared theta. And I'll probably just leave that for now. I might have to come back and do something extra with it in a minute, but at the moment that seems good enough. The denominator, if I work on that separately, denominator is sec squared theta plus cosec squared theta. So sec is 1 over cos, and cosec squared is 1 over sine. If I cross multiply those, if I times this side by sine squared and if I times this side by cos squared, I'm going to get sine squared theta. And if I times that by cos squared plus cos squared theta over sine squared theta cos squared theta. Oopsie. So all I've done is cross multiply there, times this whole side by sine squared, times this whole side by cos squared, and put them over the common denominator. We know that sine squared plus cos squared is 1, so that will simplify to 1 over sine squared theta cos squared theta. And I don't think there's anywhere that's going to be advantageous for me at the moment. So I've worked on the numerator and got that. I've worked on the denominator and got that. So if I put them back together, the numerator, cos theta over sine squared theta, over the denominator, which is 1 over sine squared theta cos squared theta. Right, partly this looks horrible, and partly we know that whenever you divide by a fraction, what you actually do is flip it and multiply. So I can turn this cos theta over sine squared theta, the numerator, divided by the denominator, and when you divide by a fraction, you flip it and multiply. So sine squared theta cos squared theta. I can see that the sine squared on the bottom is going to cancel with the sine squared, which I'm multiplying by, which leaves me with cos times cos squared, which is cos cubed, which is exactly what I wanted to prove. So I have shown that this is equal to this. Okay, looked really untidy in the middle, but all came out nicely in the end, which is often the way with trig. And the second part says, hence explain why this equals 8 has no solutions. So I'm going to try and fit that on the bottom if I can. Green. So if I started with the, I've put it off the page. Oh, do you know what? I'm going to go on to a new page. So the question said, try explain why cot theta cosec theta over sec squared theta plus cosec squared theta equals 8 has no solutions. Well, we worked on this in part A and we turned that into cos cubed theta. So in part A we already did that and we knew it was equivalent to that, equal to 8. So why does that have no solutions? Well, if you cube rooted both sides, you'd have cos theta is equal to 2. You know from your cos graph, what's the maximum of the cos graph? 1. What's the minimum? -1. Cos only exists between 1 and -1, so there are no solutions where cos of theta equals 2. It's not possible. So that's why there are no solutions to that equation. Right, I would like you to try these. So I think I'm probably going to say stop it now. Stop the video and work on these, and I'll make another one with the solutions on.